All right, let's take a look at the Chapter 11 review. It's the last exam. And our course ends Wednesday. So the exam is due by Wednesday or proctored on Wednesday. And the 11.7 questions, they're just about the other questions that we came across in Chapter 11. It's identifying the type. So simple interest, future value, that type of thing. And we are identifying them the whole time. That's how we choose the correct equation to begin with. So there, it's like a review chapter section there. Okay, so let's take a look at our first question. Use estimation to select the best response. Do not calculate. That's always a tricky thing. So if you purchase a $2,400 item and pay for it with monthly installments for 2 years, then the monthly payments is which of the following conditions? The $100 per month, the more than $100 per month, or the less than $100 per month. We won't calculate it, but we can still write out an equation. So monthly payments are future amount divided by n, because future amount is the amount you're borrowing plus the interest that they're charging you. And so if we have just P divided by T, where T equals 2, giving us N equals 24 months, that alone would be $100, but they're also charging us interest. So it's going to be more than $100 per month. It's going to be the $100 plus some amount of interest. Number two, if you purchase an item for $1,290 at an interest rate of 9.8% and you finance it for 1 year, about how much is the amount of the add-on loan? Okay, so just thinking about kind of what we were just looking at, right? This is 1,300 about, and our interest rate is about 10%. So if you were being charged about 10% on about $1,300, then you would expect to pay $130 in interest. Sorry, the dog's scratching. Okay, number 3, find the amount of periodic payments necessary for the deposit of a sinking fund. Okay, so we have A, and we're talking about a sinking fund. So go to your formulas, look for sinking funds, right? Here we have the word sinking fund, and here we have the A. So that's the equation that we're going to use. All right, so they gave us, let's see, the equation M is equal to A times R over N over 1 plus R over N raised to the NT. take away 1. Okay, so now you're just going to plug and chug, right? We have a future value A. We have an N equal to 12 because the frequency is monthly. We have a rate of 7%, and we have a T of 35 years. So you just plug all of that information into the calculator. And you get 24985. So rounded to the nearest dollar and cent, we have $24.99 being the periodic payment necessary to deposit in this sinking fund in order to have $45,000 in 35 years. Now, they just give us the equation on this one. So you just fill it out, right? So here we have 14,000 times 0.06 divide by n equals 12. So divide by 12. That's our numerator. Then our denominator is 1 minus the quantity 1 plus 0.06 divided by 12 raised to the negative 12 times 9. And you stick that in your calculator, you get the value 168.08080. And then you know that you have a monthly payment of $168.80. So we just use the formula that they gave us, found the value that they asked for, and voila. Okay. Number 5, use estimation to select the best response. Do not calculate. So again, these two go together. So we'll look at them kind of together. If you have a credit card balance, if your credit card balance is $955, you make a payment of $50, the APR is 12%, and the interest is calculated according to the average daily balance method, then the finance charge is which of the following? Okay, so if we were using the previous balance, we would have the 0.955 as the finance charge because the previous amount was $955 and our interest rate is 12%, but it's a monthly situation, so we're dividing by 12. So we're just taking actually 0.01 times 955, and this would be the value that we would calculate. So they told us not to calculate, but we still are in order to estimate, right? So the original value times an amount. would give us 9.55, right? If we were to take the $50 off, we would be at 905 times that 1%. And we would then have the 905 for our adjusted balance. Because we're looking at PRT on that one. This one's P minus $50 times RT. So adjusted, slightly smaller. So the choice in the middle is going to be the choice for the average daily balance, because that one takes into consideration both of these values, right? The lower one and the higher one. Okay, so our answer for the average daily balance. Now on the second one, we're asked a similar question, only this time they're asking for the previous balance method. And so just like above, we know it's the 910 based off of the $910, the previous balance. The APR being 12%, when we look at R divide by N, right, as our interest rate for the month, we're looking at 12% divided by 12, which is the 1%, which I was also looking at above. So 1% of this value, if we use the previous balance method, is 9.10, where then the 840 would be the adjusted and the 844 would be the average daily balance. So those ones, they're just asking us to try to imagine the three situations and where they would rank in comparison to each other for the credit card situations that we looked at in 11.2. Okay, clear that out. Here, they're asking us to find M from the equation for sinking fund. I believe we already looked this up once. That was M equals A times R over N divided by 1 plus R over N times NT minus 1, which is 120,000 times 0.07 divided by N. N is 4 because we have a situation that's being compounded quarterly. So divide by 4. And then the denominator is quantity 1 plus 0.07 divided by 4 raised to the 4 times 35, take away 1. When we stick this into the calculator, we get 202.989. Therefore, the periodic monthly payment that we need to, well, it's not monthly this time, it's quarterly. So the quarterly payment we need to deposit is $202.99. Okay. The next one, we're asked to look at the annuity formula. So we'll go look at the chart for annuity. And they're asking us just to find the value of the annuity. We know M, so let's go to our formula sheet, look for annuity. There's annuity. We know M. Here's ordinary annuity. They're asking us for not the present value, but the future value. So find the value of the annuity. They'll ask you to find the present value of the annuity if they want you to use this other equation. So we're going to use ordinary annuity equation. And we're looking at number 7. Oh, no, sorry. We did number 7. We're looking at number 8. Okay. Okay, we found the formula A equals M times the quotient, where the numerator is the quantity 1 plus R over N raised to the NT minus 1 divided by R over N. And now we just find our values and do some plug and chug, right? Annually means N equals 1. And we have our interest rate we need in decimal form. So you just fill it in, stick it in your calculator, and find the answer. This chapter is less exciting because it's just formulas and getting your calculator work right. And knowing how to round and use our dollar and cent notation. So in the future, in 20 years, if we deposit $5,000 a year, we will have $183,927.96 in the bank. All right, number 9 asks us to classify the type of financial formula for the given information. So this is one of those 11.7 questions where you're just asked to identify or classify, as they name it here. So we're looking at a lump sum problem, and we have the A is unknown, but P is known. So we have some just regular lump sum problem. For example, and this is future value. So whichever formula we're using, we don't have A. So let's go see what formula we actually should be using, because that's the compound interest formula. Yeah, there's lump sum. Lump sum. Okay, so the lump sum problem on the formula sheet where we are looking for a future value. Okay, so here they just give you the formula. You find what they're asking for. So again, a lot of this test and review is just, can you get the calculator work right? All right, so M is our 150. And N, they tell us, is 12. So we have in the numerator 1 minus quantity 1 plus the rate 0.06 divided by N, which is 12, raised to the negative 12 times 30, and then divided by our denominator, which is R over N, 0.06 divided by 12. You stick all of that into the calculator and get 25018.742. Therefore, this is $25,018.74. Okay. Now, the next one's a nice one. It's a chapter 7 question, but we also get to use the formula afterward. So we don't just have to decide which formula, but actually get to use it. So here, what is the future value of $114,000 invested for 5 years at 12% compounded monthly? The type of problem, they just flat out tell us, right? Future value. What's the future value? And this is a compounded problem. So the lump sum, like we were looking at before, so A equals P times 1 plus R over N raised to the NT. So fill in your equation. 1, 2, 3. Okay, so N is 12 because it's compounded monthly. And otherwise, you stick that in your calculator, you get 207,103.423. So we have 207,103 and 42 cents. So always look at the next decimal place so that you can round to the nearest cent. In number 12, we have find the annuity. So they're telling us what to do, right? Find the value of the annuity at the end. So the value of an annuity at the end, they're asking us to find A. They have given us M. So that helps us find our equation, right? We have the formula sheet here. So look for annuity. So here's ordinary annuity where they're asking us for A and they're giving us M. So they give us A is equal to M times 1 plus R over N raised to the NT, take away 1, divide by R over N. N is 4 because we have interest being compounded quarterly. And otherwise, you just plug and chug 1250 times quantity 1 plus 0.05 divided by 4 raised to the power 4 times 25, take away 1, divide by 0.05 divide by 4. This spits out 246,340.427. So we have here $246,340.43. So in the future, 25 years of putting $1,250 in 4 times a year, we have this much money at the end. All right, so we're about halfway done. On this one here, we are using the present value of the annuity. They give us the formula, so you just plug and chug. They tell us what everything is, so you just fill it in. 1050, 1 minus, 1 plus, 0.05, divide by 12, raised to the negative 12 times 7. That's our numerator. Divide by 0.05, divide by 12. Stick that in your calculator. And we get 74289.426, which is $74,289.43. So grade wise, you pick the right formula, you fill it in correctly, you round correctly, and use correct notation, right? I can't grade on much here. It's just calculator work. They picked the formula for us, right? So it's right or it's wrong in the end. All right, so find the value of an annuity at the end. We've done this one repeatedly, right? So we have A equals M times 1 plus R over N to the NT minus 1 over R over N. You stick that in the calculator. So semi-annually is N equals 2. And what do we have here? So we have 250 times the quantity 1 plus 0.04 over 2. Oh, I'm getting scrunched. Raised to the power 40 minus 1 all over 0.04 divide by 2. Stick that in your calculator and you get 15100.495. So we have $15,100.50. All right, convert the credit card rate to APR. Round your answer to the nearest percent. So we have this daily rate here. So they're telling us that the daily rate is 0.05049%. So the interest rate, the APR is R equal to this percent times 365. When you stick that in the calculator, 05049, you get 18.42885%. And they said to round to the nearest percent. So 18. In 16, they say to use estimation to select the best response. Do not calculate. When using the average daily balance method for the month of June, T is which of the following? June has 30 days out of the 365 days in the year. In number 17, we're asked to find the monthly payment for a loan. And let's see. Monthly payment. Let's go look at our chart over here. So here we have a monthly payment, but that has future amount. Here we have a monthly payment where the present value is known. Okay, so let's look back at our problem. Find the monthly payment for a loan. So we're financing this present value, P. So this amount we're borrowing, right? P, for an apartment complex with that percentage. So they're asking us to find M, and they're giving us P, because that's the amount it costs right now. All right, so our formula is the amortization formula then. And we just write it down, plug it out. So the rate is 0.052, decimal form, divided by 12. Okay, 1 minus 1 plus 0.052 divided by 12, then raised to, well, I guess I don't have to put the caret, negative, and is 12. We've been using that times 20. So N is 12 because they're asking us for a monthly payment. Okay, so you just stick that through the calculator and you get back 5730.801. So that is $5,730.80. So that's going to be the monthly payment for the loan to finance this apartment complex. That doesn't seem too bad. I think you could get that back in rent easily, right? Okay, so on this one, number 18, they're asking us which is better, the lump sum or the annuity. So we're going to look up the annuity formula and compute for annuity, right? So an insurance policy offers you the option of being paid the monthly payment of $750 for 20 years or the lump sum of 100,000, which has more value if the current rate of return is 4.5% compounded monthly. So we need to look at an annuity where we want to know the future value of that annuity. So let's go look, because we don't want the present value. We want the future value. Okay, so we go look up this formula and write it down and then plug and chug. Most of this review is making sure you can do your calculator work. So practice getting the correct answers. Make sure your answers match my answers. Or do your answers in the review and so on. So here you get 291,093.27, which is significantly higher than the lump sum. So we're going to choose the annuity. It's more money in the long run. Okay, so in number 19, they give us the formula. They tell us what to look for. They tell us what to plug in. So again, you're just making sure that you can get the calculator to output the same answer. Okay, so P times R divided by N, all of that's given. 1 minus 1 plus R divided by N raised to the negative N times T. Not very interesting problems. Just, can you stick it in a calculator? Can you round correctly? If yes, then you get the points. If no, then you do not get the points. So simple, but you have to practice. You have to practice being able to get it in correctly. That way you can get it out correctly. But getting it out correctly is also rounding correctly. So knowing where the cent location is and how to round to that cent location by looking at the next place value. Okay, number 20, we have find the monthly payment. So they tell us what to find. They tell us what we have. So M, and we're trying to finance this. So that's P, right? Let's see. We have that formula from before. R over N, 1 minus 1 plus R over N minus and T. Okay, so plug and chug 450,000. The rate is 0.075. Zero point zero seven five divided by 12 because it's monthly. Our denominator is 1 minus the quantity 1 plus rate divided by N raised to the negative N times T. Okay, double check. Enter everything in correctly. Then the calculator spits out 3146.465. And we know that is $3,146.47. Check, check. Okay. All right, another one of the 11.7 questions, which we have to do every single time anyway when we go look up a formula, right? We're like, what did they give us? What are they asking for, right? Here they're asking for M. Oh, M is known, actually. Periodic payment problem, or M is known. P is unknown, right? And P stands for the present value. So this question is the present value of an annuity. So that's those ones, right? 11.7. And now in number 22, Clear Lake Optical has a $50,000 note that comes due in 4 years. The owners wish to create a sinking fund to pay for this note. If the fund earns 3.5% compounded semi-annually, that's twice a year, how much must each semi-annual deposit be, rounding to our nearest cent? They're asking us for M. How much must each regular monthly payment be? So what is M? When we know that in the future, we're going to want the account to have $50,000 in it. So that's the formula where we're looking for M and we have A, right? So sinking fund, M, we have A. So this first formula, and we've got M equal to A times R over N divided by 1 plus R over N to the NT minus 1. Plug it all in, 50,000 times R. So R is 0.35. Divide by 2, because this time around N equals 2. And then in our denominator, we have 1 plus 0.035 divided by 2 raised to the 2 times 4, and then take away 1. And that's our denominator. When you stick that in the calculator, we get 5,877,146, and that is $5,877.15 for 22. The second one, they just give us the info, right? So on 23, just literally plug and chug. So M equals 50. And then our numerator, 1 minus 1 plus rate divided by 12 raised to the negative 12 times 5 all over the rate divided by 12. We stick that in the calculator, you get 2,586,278, which we now know is $2,586.28. All right, last two. All right, so this one, we've got the owner of Oak Hill Squirrel Farm deposits $2,000 at the end of each quarter. So the deposit is the $2,000. Quarters are N equals 4 into an account paying 1.5%. So R equals 0.015, compounded quarterly, N equals 4. What is the value at the end? So A equals question mark of 8 years, 6 months. So T is 8.5. So M is known and A is not. A is what we should find. So we need to go look for finding A when given M. So an ordinary annuity equation it is. Okay, so hey, look, that's the same formula right there. So we'll just use that formula twice and then we'll be done. Okay, so that formula is over R we're in. So we'll plug it in, 2000 times the numerator 1 plus 0.015 divide by 4 raised to the 4 times 8.5 minus 1, and then divide by 0.015 divided by 4. This is equal to 72380.803, which is $72,380.81. So let's see. So the owner of the Oak Hills Squirrel Farm will have $72,000 at the end of 8 years and 6 months. $72,380.81. We do another round of that same equation for the last problem here. So A is $150 times 1 plus 0.06 divide by monthly. So N equals 12 in parentheses. Raised to the power 12 times 40, take away 1, all over 0.06 divided by 12, which is, double check, everything's correct, which is 298,723.610. So we have $298,723.61 for number 25. So this test is really just, can you identify the correct formula? Can you fill in the formula correctly? Can you export the answer correctly and round? So, and then we're done. So let me know when you have questions. And otherwise, thank you.